I want to welcome you for today's class, whereby we shall be covering Rolle's theorem and the mean value theorem. Basically, functions, to be able to find a number C or K that is between a particular interval. So the mean value theorem says that if a function f of x is, number one, continuous. First of all, it has to be continuous in the closed interval AB. And then number two, it has to be differentiable on the open interval AB. Then there exists a number C. No, before you go to the number C, and if f of A is equals to f of B, basically when you replace your end of the interval with the end of the other interval, you'll still be able to end up with the same thing. Then there exists a number C. Number C, such that f prime of C is equals to 0. So the prime means we shall be able to differentiate the C ones. So this is basically the what? The literature for the Rolle's theorem, that if a function is continuous, and that is closed interval. Closed interval means we are considering the A and the B. The open interval AB on the differentiability, we shall not be touching A and B. And if f of A is equals to f of B, then there exists a number C such that f prime, when you differentiate f of x and you replace C, you'll be able to get it to 0. Let's do an example to demonstrate this. Example, we verify this one for the mean value theorem. F of x will be given by x squared minus 2x minus 8 in the interval -1, 3. So now, first of all, for us to be able to solve this one using the Rolle's theorem, first of all, we must be able to do some things on differentiability and continuity. So the first thing I'm able to say is, since this function, since f of x is a polynomial, all polynomials are, it is what? It is continuous on the closed interval, what you have been given 1, 3, and differentiable in the open interval -1, 3. So all polynomials, basically, they are what? They are continuous and differentiable on a certain interval. Rarely will you be able to find polynomials that are what? That are discontinuous. So this function, we can still be able to differentiate it. We'll get 2x minus 2. So all polynomials. So we don't need to do a lot of proving. You can just go to the basics that all polynomials are continuous and differentiable. Very important. All polynomials so that's one feature that we need. Now we need to find our A and our B. So our interval is given by -1 and 3. So this one means that A is -1 and our B is 3. Basically the interval that we have been given. So we shall be able to come and find f of A. That is f of -1. We replace it basically in the function you have been given. So -1 minus 2, -1 minus 8. So this one I'm getting it as what? -1 plus 2, -1 plus 2, that is 1. So I'm getting this one as -7. Again, I'll do f of B. that is f of 3. I replace it on the function I've been given, x squared minus 2x minus 8. And I replace, I'll get. Have I done this one correctly? This one wrong? So this one was supposed to be squared. If that is squared, I'll be able to get a different answer. That is 1 plus 2. That is 3. So negative 5. Putting here negative 5. So I do this other one of 3. Again, I replace 3. So I have 3 squared minus 2 times 3 minus 8. 3 squared, that is 9. 9 minus 6, that is 3. And then you get negative. I'm getting negative 5 for that one. You can easily be able to see that our f of a is equal to f of b, which means that our f of a is equal to f of b, which is the same as what? Negative 5. So for the Rolle's theorem, for you to be able to come and proceed, first of all, you have to confirm that your f of a is equal to f of b. What if you find that they are not equal? Then you cannot be able to continue with Rolle's theorem. It is impossible to continue with Rolle's theorem. Now, the next step, you are given our f of x up there, was given by x squared minus 2x minus 8. So because f of a is equal to f of b, we said we can be able to find a number c such that f prime of c. First of all, I'll be able to come and find f prime of x first of all. F prime of x here is 2x. We just differentiate minus 2. Now f prime of c now will be given by, you replace the c, you'll get 2c minus 2. And we say now there exists f prime of c such that f prime of c is equals to 0. So I'll solve for this one. So 2c has to be the same as 2, and c is equals to 1. If you check the interval that we are given this interval 3. When able to see the value 1, it is strictly in between negative 1 and 3. It is strictly in between negative 1 and 3. It is strictly. So it obeys Rolle's theorem. Let's go to number 2. F of x is equals to negative x squared plus 6 minus 6 on the interval 1, 5. Do this one on the interval 1, 5. Now, the first thing is to confirm the literature for Rolle's theorem. Since f of x is a polynomial, it is continuous on the closed interval 1, 5, and differentiable on the open interval. You just change the brackets 1, 5. We shall come back to this one, don't worry, on the closed and the open interval, what we mean. So this one now, we have been able to, at least because it is a polynomial, so that is the first thing that we do. The second thing is to come and find our a and our b given in the interval. So our a is the endpoint on the left, and our b is the endpoint on the right. So we confirm if our f of a is equals to f of b. So first of all, I will do f of 1. I replace it there in the equation, so I'll get negative 1 plus 6 times 1 minus 6. This one I'm getting this one as negative 1. I do f of 5. That is negative 5 plus 6 times 5 minus 6. It's like that. Let me confirm. I believe it is like that. So sorry again, I'm forgetting. It is squared. It is squared. So it was 1 squared like that. The negative will still remain outside. So this one, you have to be careful with the negative. This one I'm getting negative 25 plus 30 minus 6. The negative will still remain. So negative 25 plus 30, that is 5. 5 minus 6, you're still getting negative 1, and you can be able to see that they are equal. So f of 1 is the same as f of 5, which is the same as negative 1. So you can be able to proceed. If they're not equal, please don't proceed. So the next thing is to come and differentiate this one. We get f prime of x, and then we replace with the c, and we equate that one always to 0. So I'll come to our f of x. Our f of x was given by negative x squared plus 6x minus 6. So f prime of x will be given by negative 2x plus 6. So f prime of c will be given by negative 2. That is an x I replace with c plus 6. So there exists f prime of c such that this one will always be equal to 0. So I'll solve. Negative 2c is equals to negative 6, and here c will be given by 3. Let's check our interval. Our interval was 1, 5. And you can be able to see that what? The number 3 is between 1 and 5. It is strictly between 1 and 5. It's strictly between 1 and 5. Example number what? Number 3. We confirm this one. The interval 2, 4. The Rolle's theorem. So first of all, see f of x still is a polynomial. Is a polynomial. Because it is a polynomial, it is what? Continuous. Please don't get tired of doing this. It is continuous on what? On the closed interval 2, 4. Oh, sorry, and differentiable on the open interval now 2 and 4. 2 and 4. Now what we need to do now is to be able now to confirm. The interval is given 2, 4. So we get our A. Our A is the endpoint on the left, and our B is the endpoint on the right. So we replace there. So f of 2 then will be given by our number 2 squared, which is the same as 4. Then our B, f of 4, will be given by what? 4 squared, which is the same as 16. So we confirm if they are equal. These two, are they equal? No, they are not equal. So you can able to conclude that f of 2 is not equal to f of what? F of 4. Hence, Rolle's theorem cannot be verified. Cannot be verified. Why? Because the Rolle's theorem, we said that our f of a has to be the same as our f of b, and you can be able to see our f of 2. The numbers that we are getting are totally different. We have 4 and 16, so we cannot be able to verify for Rolle's theorem, and we just end there. Let's do the final one, number 3. F of x will be given by 2x minus x squared minus x to the power 3 in the interval negative 2, 1. So again, I'll not do the literature. The first thing we need to come in and say that if f of x is a polynomial, you can be able to see. So it is continuous on the closed interval negative 2, 1, and it is differentiable on the open interval 2, 1. So that is very, very important. So you must be able to state that. So our next step is to find our what? Our a, the endpoint on the left, that is negative 2, and our b, the endpoint on the right, which is 1. So we confirm if these two are equal when we replace in our function. So let's do f of a. That is f of negative 2. We replace basically in the function, so 2, negative 2, minus negative 2 squared minus negative 2 raised to the power 3. Let's put all this in the calc. So we have to this one I'm getting the first one as 0. Then we do our f of b, and our b is 1. So we replace again where there's an x with 1. So where these brackets, I'll just replace 1 minus 1 squared minus 1 raised to the power 3. Again, when you do this one, you still get a 0. So you can be able to see that our f of a is equals to f of b, which is the same as 0. So we can be able to proceed to verify Rolle's theorem because they are equal. The next step now is our function. We differentiate once. So f of x was given by this one, 2x minus x squared minus x to the power 3. So when you differentiate this one once, that is the prime, you get 2 minus 2x. The power comes down, you reduce the power by 1 squared. So we get our f prime where there is an x, we replace with c, 2 minus 2c minus 3c squared. And these one we always equate to 0. So if you can be able to check, this one has become a quadratic equation that I need to solve. Whereby, let me rearrange it in a better way. So I have negative 3c squared minus 2c plus 2 is equal to, this is a quadratic equation. Where our a is negative 3, our b is negative 2, and our c is 2. So let's solve for c. So c will be given the quadratic formula negative b plus or negative b squared minus 4ac all over 2a. So let's solve this one and see what you're getting. So our b will be positive. So b squared, that is negative 2 squared minus 4. Our a is negative 3. Our c is 2. And our a is negative 3. This one, when you solve, I'm getting 4. 4 minus 4 times negative 3 times negative times 2. I'm getting a weird answer. That is 4 times 3 times 2, then plus 4. Still okay. I'm getting 2 plus or negative square root of 28 all over negative 6. So I do the first one. The first one answer for C will be 2 plus square root of 28 all over negative 6. Let me see what I'm getting. Square root of 28 plus 2 and divided by negative 6. I'm getting negative 1.215. The next answer that I have for C will be the negative, and then all over negative 6. So 2 minus square root of 28 divided by negative 6. So 0.5, let's say 55. Now we go back to our interval that we are given. The interval that we were given, it was this one. Let's go up because we have two answers. So we want to check which between those two answers, which one is between the interval we are given. Our interval is negative 2, 1. Negative 2, 1. So I go down. Negative 2, 1. So I write here the interval negative 2 and 1. So I confirm between these two values, which one will be in between the interval? Which one will be in between the interval? And we can be able to see all values are in between the interval. That is correct. 2 plus square root of 28, then divide by negative 6. Negative 1, that's okay. 2 minus square root of 28 divided by negative 6. Okay, so you can be able to say we shall still be able to take all the values because they are in between the interval. So we have two numbers that are in between, and still in some cases you'll only find one number. So you'll only find that one number is in between the interval. What you normally do, you just have to pick at least one that is in between the interval. So we are done with Rolle's theorem. We are done with Rolle's theorem for that. I hope you'll be able to follow on the mean value theorem. So let's go to the mean value theorem. The mean value theorem, or the MVT. Mean value theorem. Mean value theorem. Sometimes we call it the MVT. So the mean value theorem says that if a function, given a function f of x, on a particular interval AB, they've been given a function f of x on an interval AB, and if this function f of x, number one, it is what? Continuous. The same as the first thing, continuous on the interval AB. Number two, it has to be differentiable. Differentiable on the open interval. So when I use this bracket, it means open interval. We shall do this one in the next class, the closed and the open interval. If f of x given on a particular interval, it is continuous on AB, differentiable on AB, then they exist. They exist a number k. So just to differentiate, you can use any letter, but we normally use k. Exists a number k. Number k such that such that such that f prime of k will be given by f of b minus f of a all over b minus a. So on the MVT, mean value theorem, we don't check if f of a is equals to f of b, but we just go and apply the formula. So there will always exist a number k that is between a and b, such that f prime of k will be given by f of b and minus f of a, b minus a. So this is the formula that you need to remember if you want to do the what? If you want to do the MVT, this one here, that is the formula you need to remember. Let me do an example. So that is the formula you need to remember. It's a bit different from the Rolle's theorem that we have done. You'll be able to go through that. You can do an example to demonstrate this. Number one, f of x is given by negative 2x to the power 3, 6x minus 2 on the interval negative 2, 2. So what are we doing basically? We are just looking basically for value k that will be in between these intervals. That's what we are just checking. And there are some theorems that were proposed, and those are the theorems that we are doing. So for this one, first of all, we shall say, because it is a polynomial, since f of x is a polynomial, that's the first thing you go. It is continuous. It is continuous on the closed interval -2, 2, and differentiable on the interval -2, 2. So the interval will always be given, so you don't have to worry about that. So I'll go back now to the formula. There exists a number f prime of k such that f of b minus f of a. So this is the formula that we want to use. So I'll go back to the interval that we have been given on the function. So we have been given -2, 2. So it means that on the extreme right, this one here, if I compare this one with AB, it means that our A is -2 and our B is what? 2. So I've been able to find the value of A and B. That is what it means. Our A is always on the extreme left and our B. Now, according to the formula, we need first of all to find f of B and f of A. How do you find that? We have our function. So we shall replace our A on the what? On this function that we have been given here, this function here. We shall replace our A there, then we replace our B and get some values that we shall be able to use. So let me replace. So I can be able to start with f of A be the same as f -2. So where there's an x, I replace with -2. So I'll have -2, -2, and then let me see up there -2, and then our x raised to power 3. We'll have -2 raised to power 3, and then what? Plus 6x minus 2. 6, where there's an x, I replace 2, and then minus 2. So we do that one with a calc. Then now we do our f of b. Our f of b is 2. So again, whatever that's in brackets, I will interchange with 2. Minus 2. So the first one, let me confirm with the calc. It is -8 times -2. 16 minus 12 minus 2. I'm getting this one as 2. The other one is 8 to raise to power 3, that is 8 times -2 plus 12 minus 2. I'm getting this one as -6. Hope that is correct. -16, -18, yes, it is correct. So that's what first of all you do. So according to the formula still, we need to find f prime of k. So f prime of k will be gotten from, first of all, our f of x. So our f of x was given by this one. Our f of x was given by -2x to the power 3 plus 6x minus 2. So we differentiate this one once. We differentiate once. F prime. So the power will come down and remain with -6x squared. When you differentiate, you just get 6. Now, our f prime of k now is where there's an x replaced with k. So I'll get -6 k squared plus 6. Only that. So you just have to replace. So now I have everything that I need. I just input them in the formula. So f prime of k we know. Our f prime of k we know. That is -6 k squared plus 6. Then we go to the formula. Our f of b. Our f of b we got it as -6. -6 minus our f of what? Our f of a. The formula, our f of a is 2. excuse, all over our b was the interval, so 2 minus 2. So 2 minus 2, because our a is minus 2. So this one, when you solve, what are you getting here? This side here. So you're getting negative 8 all over 4. So I'm getting negative 6k squared plus 6. And then negative 8 divided by 4, I'm getting what? That is negative 2. So this one is a quadratic equation, please. So I'll rearrange 6x squared plus, no, it's not a quadratic equation. This one is easy. We bring like terms together and solve. Sorry, it's still a quadratic equation, but we just solve easily. Bring like terms together. To bring like terms together, so negative 6k squared has to be the same as what? Negative 2 minus 6, which is the same as negative 8. So k squared will be given by negative 8 all over negative 6, the same as what? This one will be the same as, is it 4 over 3? So let's solve for k. So k, the first one, k will be given by the square root of 4 over 3. So we shall have two answers, one that is positive and the other one that is negative. So let's do the square root of 4, 3. I'm getting, the first one will be 1.1, let's say 55. The other one will be negative 1.1. Because for the square root, for squared, we have two values. Now we go back to the interval that you are given. So the interval that we are given is this one here, negative 2, 2. You'll be able to see the interval that we are given is negative 2, 2. So negative 2, 2, we confirm which value is between there. The interval that we had is negative 2 and 2. So we confirm between these ones, which one is in between the interval, and we can be able to see that all of them are in between the interval. So we take all values. So there are two numbers that are existing on that interval. There are two of them, because all of them will be between this interval here. So let's do number 3. But number 2. F of x is given by x squared on the interval negative 1, 2. So in the previous example, what we have done, we have said for the continuity and differentiability, we just say that this one is a polynomial. So it will be continuous on that interval negative 1, 2, and it will be differentiable on the interval negative 1, 2. So that is the first wording that you start with. That is the theory that we have gone through. Now, the next step is to go back to the formula for MVT. It means that there exists an f of k such that what? F of b minus f of a all over b minus a. So this formula is very important if you want to do. So if you forget about that formula MVT, you cannot be able to do it. So what we just need is to calculate f of b, f of a, then f prime of k, and we are done. So I'll start with this interval here, negative 1, 2. Will always be given this one. So if I do a direct correspondence, it means that our a here is what? Our a is negative 1, and our b is what? 2. If you check AB, our a is negative 1, and our b is 2. Now, according to the formula, I need f of what? I'll first of all get f of a, the same as f of what? Negative 1. So I'll replace this one in my function. My function is x squared. So I'll take negative 1, I square it. I get this one as 1. Then I'll do f of b. Our b is 2. So I replace 2 on my function x squared. So where is an x, you replace with 2. So I'll get this one as what? 4. So I'm done with that one. The next step, they are saying I need f prime of k. So before I get f prime of k, I need first of all to have f of x. And f of x have been given. So our f of x is equals to what? X squared. So what I need to do is to differentiate this one once. So we are putting prime. You just differentiate one. Prime means you are differentiating only once, you get 2x. Now, according to the formula, they are saying they need f prime of k, not f prime of k. So where there's an x, I replace with k. I'll get 2k. So my work now is almost done, is to replace everything on the formula. So our f prime of k we have gotten, which is 2k. Then I go to the formula, our f of b. Our f of b is we got f of b as 4. That is 4. Then we got our f of a. Our f of a was 1, so I subtract 1. I go to our b. Our b, we got it as 2. And our a was -1. When you do this one, you are getting 3 all over 3. So 2k has to be the same as number 1. 3 over 3 is the same as 1. So k has to be the same as what? Some people will say a half, or people will say 0.5. Let's go back to the interval that we have been given and check if that number is between there. So the interval that we have been given is -1, 2. This is the interval -1, 2. If you draw the number line, -1, 0, 1 and 2. So you can be able to see our value is somewhere here, is somewhere there. And you can be able to see is in between the interval. So we are okay. We have been able to find the value of the constant k. Let's do another one. The last one now, number 3. It is easy as that. Given f of x is equals to f of x is equals to x to power 3 plus x squared minus x on the interval -2, 1. We do this one. So the first wording I'll have to put there is since f of x is a polynomial, it is continuous on the interval -2, 1 and differentiable on the interval -2, 1. So that's the first wording we do. So you must be able to write that one down, and we have done that one in the previous example. So after you do that, we go now to the formula for mean value theorem. F prime of k will always be given.
Excuse me, sir.
Yes.
The video is
So you are on the mean value theorem, and you are saying that this is the literature for the mean value theorem. You'll be able to find them on the notes. That given a function f of x on a particular interval ab, first of all, it has to be continuous, and then it has to be differentiable on the open. So the first curly bracket means it is what? This one means it is closed. We shall come to this one in the next class. This one means it is open, open, open. Then this formula, then it says that there exists a number k such that this one will be satisfied. This one will be satisfied basically, whereby you have f prime of k, whereby we differentiate our f of x and then we replace our k. Then we have f of b minus f of a and then b minus a. So I did the first example. This is the function that we have been given. F of x is equals to -2x squared plus 6x minus 2, and then you'll always be given the interval here. So now, the first thing we check, this one is a polynomial. All polynomials are what? Continuous and differentiable on the given interval. All of them, basically, they are. So first of all, we go back to the formula. This is the formula that we need. And there are some things that we need to calculate first of all. So on the interval, first of all, we need to get the value of a and b. And we have said, if I do a direct correspondence here, if I do a direct correspondence, you'll be able to see here that my a is -2, and this one here. My a is -2, and our b is 2. So that's the first thing we have found. Then we need our f of b and our f of a. So we replace the value that we have gotten for a and b in our function. The function here, the one that is here, f of x, we replace it there. The value of the first one I've replaced is a. Where there's an x, I've replaced with what? With a. This is what I replaced, and I got our f of a was 2. Then f of b was 2. So I replaced again on the function. and I got negative 6. Then now I've at least dealt with the what? With the right hand side. So what I need is to get the value of f prime of k. F prime of k, we get it from what? Our f of x. So this one is our f of x. It's supposed to be f of x. So this one is our f of x. Our f of x was given by this one. So you differentiate this function once, only once. The power will come down, you reduce the power by 1. After you differentiate once, where there is an x, you replace with k. So instead of having negative 6x squared, I'll have negative 6k squared plus 6. And you can be able to see. Now, the other thing is just to apply the formula. Apply the formula, negative 6k squared plus 6, our f of b. So this one is our f of b that we got. This one is our f of b. This one is our f of a. This one is our b. And this one is our a. So I just replace it in the equation. So negative 6 minus 2, I got it as negative 8. Then 2 minus minus, I got it as 4. So when you divide negative 8 divided by 4, I got it as what? Negative 2. Now this one is almost a quadratic equation, but it is easy. There's no b. So I brought like terms together. So when 6 will cross over, it shall become a negative. So I got negative 6k squared is equals to negative 8. And then this one is just a matter of solving for k. So k squared, I got it as 4 over 3. And because I need the value of k, I look for the square root. For the square root, we need two values, which is 1.155 and negative 1.155. So we check which values are in the are in the interval, this interval that you are given, and you can be able to see that those both values are in the interval. If one value is in the interval, we only take one value. So all of them are okay. So that's the answer that we got. Then I did an example number 2, the same. We said again for the wording, we must start by saying that f of x is continuous on the, f of x is a polynomial, so it is continuous on that interval negative 1, 2, and differentiable on the open interval negative 1, 2. So that is the wording that you have to put before you go to the formula. Then again, you come to the formula, it is not still changing. You come to the interval negative 1 and 2, you do a direct correspondence. So our a is negative 1 and our b is 2. Then according to the formula, I need f of a and f of b. So I've replaced where there's an x, I replace our f of x is x squared. So where you replace where there's an x, the first value is negative 1. So I got negative 1 squared, I got it as 1. Then f of b, I replace where there's an x with 2, I got 2 squared is equals to 4. So remember, I'm replacing on the function that you have been given here. It is here. So you'll always be given that one and the interval. Now the next thing is to come and find f prime of k. So how do you find f prime of k? First of all, you must be given f of x, which is x squared. So you differentiate once again. The same procedure. You differentiate once, you get 2x. Then to get f prime of k, where there's an x, you replace with k. I did that. Now the next for a is to apply the formula. The formula is this one, our f prime of k, we have gotten as 2k. It is here. Our f of the formula says I get f of b minus f of a. Our f of b is 4 and our f of a is 1. So I subtract 4 minus 1 and you can be able to see. Then our b is 2. Then I subtract negative 1. I'll have negative minus 1. So 4 minus 1 is 3. 2 minus 1, you get 3. So I got 3 over 3 is the same as 1. 2k is the same as 1. Then you can be able to put it in either a fraction or a decimal. So either half or 0.5. Again, we go back to the interval. The interval is this one that we have here, the interval that we have, negative 1 and 2. And you can be able to see the value we have gotten for k. It is in between the interval. This is the interval that we have. It is in between what? It's found in between there. So it is here. You can be able to see it is in between. So you have been able to find the value of the constant k. Now I was on example number 3, which was f of x was given by x to the power 3 plus x squared minus x. This is the interval that we have been given. So first of all, I was you must start with the wording. Since f of x is a polynomial, it is continuous on the closed interval -2, 1, and differentiable on the open interval -2, 1. So that is the wording you start with. Then you go now to the formula. F prime of k will always be given by f of b minus f of a all over b minus a. Now, what we need is to find our a and we find our b. So given this interval here, this one will always be your a, this one will always be given by your b. Always a and b. So what I need from this one, I'll first of all get f of a. You can start with f of b, no problem, or f of a, it doesn't matter. So I'll start with f of a. Our a is what? Our a is a -2. So I'll replace -2 on the equation. So I'll get -2 raised to power 3 plus -2 squared, and then minus, and then you have to put brackets because our a is -2. I'm able to get that value. Then I'll come and do our f of b, which is our b is 1. So I'll have 1 raised to power 3 plus 1 squared minus 1. We get those two values. How do you get those values? You just replace them in the function. So the first one I'm getting -8 plus 4 and then plus 2. This one I'm getting this one as -2. The other one is 1 plus 1 minus 1. Then I'm getting this one as 1. So after getting f of a and f of b, we need now to get f prime of k according to the formula. So we get I'll repeat again, there's no need of, our function was given by this one minus x. So I'll differentiate this one once. You get 3x squared plus 2x minus 1. So that's the first thing you do to get f prime. Now you get f prime of k. Where there's an x, you replace with k. So 3k squared plus 2k minus 1. So we have everything that we need. So we need to input everything in the formula. So let's say I start with the f prime of k. Then I go to our f of b. Our f of b was 1 minus our f of a is -1. Then I go to the interval, our b was 1 and our a was -2. I'll get here 1 minus -2. So let's solve this one here. 1 minus -2, we get this one as 3. 1 minus -2, we get this one as 3. To get up to there, you get 3. So 3 over 3 the same as
1.
The same as 1, yes. The same as 1. So this one is like a quadratic equation, so we bring like terms together. So I'll bring this one, this particular side. So when 1 will cross over, it shall become a negative. So -1 minus 1 will get -2. You'll not get 0, please. You'll not get 0. They're not identical. You only get identical on the opposite side if they are identical. So when 1 will cross over, it shall become negative. So -1 minus 1, you get -2. So this one, it clearly is a quadratic equation. It's a quadratic equation. So I'll be able to solve. So k will be given by, remember the formula for the quadratic equation. K will be given by -b, for negative b squared minus 4ac all about 2 times a. So our b is what? -2. And then 2 squared minus 4. Our a is 3. Our c is -2. And then our 2 times a. Our a is 3. This one will get -2 plus or negative. Let me use a calc for this one. 4 times 3 times negative 2. I'm getting this one as negative 24 times negative 1. 24 plus 4. Almost as what I had done before on Rolle's theorem. Negative 38 all over 6. All over 6. So I'll do the first value of k. The first value of k will be the positive one, negative 2 plus square root of 28 all over 6. That's the first value. Then I'll do the other one when k is on the negative side. Negative square root of 28 all over 6. These two values. So I'll use my calc. Square root of 28. And then minus 2 divided by 6. The first value I'm getting is 0.5. Let's say 55. So that is the first value that I've gotten. The other one is negative 2 minus square root of 28. And then divided by 6. I'm getting negative 1 point, let's say 22. Negative 1.22. There's a point here, sorry. So I go back to the interval that I was given. The interval that I was given was this one. The interval that I was given was negative 2 and 1. So I confirm which two values, which two of these values are in between the interval. We have 0.55. For sure, it will be between the interval. Then we have this other one, negative 1 point. The point is going. You have a point there. Again, this value, if we check correctly, it is still in between the interval. This one here, it is still in between the interval. So we have two values. So we take all of them. There's a point here. We take both values because they are in between the interval. If you do this interval here, negative 2, we'll have negative 1, 0, and then 1. So 0.55 will be somewhere. 0.55 will be somewhere there. And then negative 1.22 will be somewhere where? It will be somewhere. So you can be able to see they are in between the interval. So we take both values. Now, I've given you an exercise on this one. You can be able to go back after this one. I know on the mean value theorem, maybe Michael, you can be able to attempt it. The Rolle's theorem, you have to get the video and you try to go through it on the Rolle's theorem. I've given 2 examples. So go and try. You can be able to see my recording has taken a lot of time, but please go and try